Good afternoon all. Today I will be talking about Flipkart's cloud setup.
Hello.
Okay.
Hello. Oh. Hello.
Yeah. I will be talking about Flipkart's cloud setup. It's an infrastructure management tool developed in-house for the provisioning of virtual machines. I'll be talking about the underlying technologies used, its different components, its architecture, its present capabilities, and our plans for the future. I will start the talk with as to why we decided to create our own private cloud. So before cloud, we used to provision physical servers both in staging and production. The amount of time required to set up the servers was pretty high. It takes around 4 hours to actually set up a single server. And you have to actually log into 4 to 5 different consoles to actually set up one server. So overall, infrastructure management was becoming pretty hectic. We sometimes used to have set up around 20 servers at a time. So then the ops engineers have to work on actually setting up the servers for days or maybe even weeks. And on top of that, these servers are expensive, due to which we at one point of time used to have just 3 staging servers, which was actually used by all the teams in Flipkart, and they would co-host their applications there. So quite frequently, one team or the other would complain that their application stopped working just because some other team actually installed a package or did an upgrade and so on. So, and most of the times, many of these servers remain underutilized. So, due to all these reasons, we actually thought of provisioning virtual machines instead of physical servers. Initially, we provisioned physical servers in staging. We tested and tuned these virtual machines there. Once it was stabilized, we also built a console on top of this virtual console on top to assist in the provisioning of these virtual servers. And that was how cloud was formed. Now with cloud, you don't need to actually log into 4 to 5 consoles to actually set up a server. You can actually provision multiple virtual machines using a simple command line tool. You just need to provide the name of the virtual machine, its size, whether it's a small or a medium or a large, then the environment, whether it's staging or production, and cloud will actually internally take care of building the host, setting up the user accounts, pushing over the configurations, installing the packages, setting up DNS, adding the host to DNS, setting the IP address, and it enables monitoring as well. So now with cloud, setting up 20 servers is like it takes less than an hour. And we currently have more than 800 plus virtual machines across all the environments. So first we will talk about the technologies that's used by cloud. It uses OpenVC for virtualization. It's a container virtualization solution. The advantage of OpenVC over other full or para virtualization solutions is the virtualization overhead is very less. But its disadvantage is you can't have different types of OSs running on the same server. But that is fine for us because most of our servers actually run on Debian. Apart from that, it provides facilities like any other virtualization. It allows you to control the system resources, be it CPU, memory, or RAM, or disk space. It allows for dynamic resizing, wherein you can actually change a small virtual machine to a medium or large on the fly without actually requiring any downtime. And it supports live migration, wherein you can actually move the virtual machines from one server to the other without disrupting any services. And then we use Puppet for setting up user accounts, installing the packages and configurations. Then we use HostDB, which is Flipkart's host database. It's a component that is central to many services in Flipkart. So I will talk a bit more about it before I proceed with cloud. HostDB, it's the source of truth for all host-related information. Every physical machine or VM in Flipkart will actually have an entry in HostDB. It will include details like the host make and model, its IP address, its Puppet classes, and any monitoring related information. And it provides a facility by which called tagging, by which you can actually group the hosts. Say all the virtual machines will have the VM tag. Similarly, production servers will have one tag and staging will have another. A single host can be associated with more than one tag. And tags can have properties similar to host. So the idea of having tags is, having properties in tags is, when one host is actually associated with that tag, it will inherit all those properties. Then HostDB allows you to search using tags. So say if I want to get the list of all the virtual machines, I can actually do that using the VM tag. This is a typical entry for this is a typical HostDB entry for a VM. It will include details like its IP address, who created the VM, its Puppet classes, the base host where the VM is hosted, and those are the set of tags that's associated with the host. Currently it has the VM tag and the production tags. This is an entry for a tag. It will have properties similar to host, and those are the set of hosts that's associated with this tag. Currently this tag has properties related to monitoring. That means the set of services that needs to be monitored. One use case of having properties with tags is, say you have a set of DB servers and you want to monitor the status of MySQL on them. You can actually create a MySQL tag and include all that information. And when you associate all the DBs with this tag, and then when the monitoring daemon actually polls HostDB to figure out what all services needs to be monitored, it will actually get that information. Any questions with HostDB or anything till now? Yeah, it's the container that you are referring to. Okay. Next, I will talk about the different components. Yeah.
You said that there is a lot of overhead with using other virtual machine solutions, right?
Yeah.
Do you have any data of what virtual machines you sampled or what technologies you sampled before you came to OpenVC?
It's actually like OpenVC, there isn't actually any translation happening, any virtualization translation happening between the virtual machine and the physical host, like with a hypervisor. So actually with OpenVC, the underlying kernel is actually same across all the virtual machines. So if you actually log into the physical server, you'll actually see all the processes running across all the virtual machines. The isolation actually happens in user space. So that's how it is. It's more like Linux containers than actually a virtualization as is. The disadvantage being you can't have different types of voices on it. That's the main problem. Yeah. So we currently, most of our servers are Debian, so we can fine with that. And the first component is the cloud front end. It actually provides both a web interface and a command line tool. The front end actually initially gets the request from the user, and then it validates the request. Meaning it will check whether the VM name is valid, whether the user has permission to create or delete the virtual machine, whether sufficient capacity is available, and so on. And later on, in case of VM create, it actually assigns a physical host and an IP address to it. And this is the architecture. In this, that is the cloud front end. It actually initially gets the request, it validates, and then it actually stores it into an SQLite database. And later on, the next command, the cloud daemon, it actually gets triggered every 10 minutes. It constantly polls the SQLite database and checks for any pending request. And it actually processes all the requests serially. So as part of processing the request, it actually initially makes an entry into HostDB. Say in case of VM create, it actually inserts an entry into HostDB, and then after that it actually connects to the physical host to create or delay the virtual machine. So that's the cloud daemon. It updates HostDB and then contacts the physical host via HTTP API call. The cloud daemon actually contacts VC client that is running on all the physical servers and asks it to actually create or delay the virtual machine. And the VC client internally uses VZCTL. It's a set of command line tools that's provided by OpenVC for manipulating the virtual machines. So in this case, the VC client actually contacts the physical host and creates the virtual machine. So as part of VM create, two scripts are run. One is post create and the other one is Flipkartify. Post create is run in the physical host context and Flipkartify runs inside the virtual machine. Post create is run after VM is created, but before the VM is actually booted up. So what it does is it will get the basic network information from the physical host, like the location of the DNS server, the default gateway, the location of the Puppet server, and it copies over the SSH keys, and then it sets up Flipkartify such that it is run as part of VM boot up. So once the VM is booted up, Flipkartify is run, which actually sets up the time zone, installs Puppet client, and then later on it triggers Puppet. So Puppet internally contacts the Puppet server, which in turn contacts HostDB to figure out the set of classes that's associated with the host. Using that, it generates the manifest and sends it back to the virtual machine. And later on, Puppet actually takes care of rest of the initialization, like installing packages and so on. Apart from that, then there is the DNS update script. It actually runs on all the DNS servers. Its job is to actually poll HostDB periodically using the VM tag to see whether a new VM is created or deleted and accordingly updates DNS. So that's the DNS server. It polls HostDB to update DNS. Then other services also poll HostDB, like the monitoring services Nagios or Munin, and then it enables or disables monitoring as accordingly. So this is the web interface of Cloud. It currently provides features to create a virtual machine, delete it, modify an existing virtual machine, meaning you can actually rename or resize the virtual machine. Both are done on the fly without a downtime. Then it has the option for reservation. Reservation is used, like say a particular team asks for 20 different virtual machines by next week, or they require it by next week or next month. You can actually reserve that capacity beforehand so that no other team actually uses that up. And it has a status page to see the how much capacity is remaining, what are the set of physical servers available in the pool, and how much capacity is actually remaining on all. It will provide all that information. And then there is the stats page, which gives stats like how many VMs were actually created by a particular user, or the overall stats, how many VMs were actually created during a period or removed, and so on. Then resize. You just provide the name and the new size. And this is the reservation page. Before doing the reservation, you have to actually provide a reservation ID so that it can be used later on to create virtual machines within that reservation. Then this is the status page or the host map. It actually shows the total capacity, how much is used, how much is remaining, and these are the pool of physical servers. It will individually show how much capacity is actually remaining in each. And if you hover over to a particular machine, you can actually see the set of virtual machines that's hosted there. Any doubts to know? Yeah. Yeah, those sizes are predefined actually. You can actually, then you have to actually create a new template with the new sizes.
I have a question.
Yeah.
So you told a bit on the Puppet configuration, right?
Yeah.
So how does that work? So you mentioned the Puppet classes, and how was Puppet set up to, where is the node added to Puppet on the server?
Where is the node?
So on the server, you need to add the node to the Puppet configuration, right?
Yeah, that's actually done in HostDB.
So HostDB does that, is it?
No, while creating the virtual machine, you actually add that classes to Puppet, add that classes to HostDB.
Right.
So, and after that, Puppet actually internally we use Puppet ENC.
Okay.
So Puppet internally contacts a script providing the virtual machine name. And that script actually internally contacts HostDB to get the list of classes, and it provides it to Puppet server. And the classes would be predefined.
Sure.
Yeah. So we just need to provide the class name and the parameters. So these are the current limitations with cloud. You can't have any network or disk intensive applications in it because these two resources are actually common across all the virtual machines. So if one process were to hog the network or do heavy reads or writes, then all the VMs will get affected. So currently we don't host database servers or as such in cloud, and we can't insert kernel modules because OpenVC, the kernel is actually common across all the virtual machines. If one, yeah.
What are the typical workloads that you deploy at this?
Typical workloads, most of our Java applications actually run on it. We currently don't host a website because it does heavy logging and all. So apart from that, most of our staging servers are in cloud. Even in staging, we actually have even databases on cloud itself. Then mostly the backend services are actually inside cloud.
So almost everything in Flipkart except the DVs or the front-end web machines are in cloud. So he mentioned that 800 VMs are there, so most of them are served in production.
I mean, not directly, but
Yeah,
they do some.
backends.
Actual front-end servers for Flipkart.
Actual front-end servers for Flipkart is not in VMs because they are having heavy traffic, so they need real boxes, big boxes. So these small VMs is not good enough there.
And those applications are actually capable to actually utilize the full resources of a particular server. So,
What prompted you to use containers and not real virtual machines?
one thing was the lowest virtualization and we actually didn't require a complete virtualization. We were not actually going to do anything with the kernel or anything as such. Most of our applications actually run on Java. We just needed a user space isolation. That was the main thing. So we went with it.
And one thing about cloud is that it is not limited to OpenVC. Say tomorrow if we want to add KVM or SEN, we can just do that. So cloud is independent of the technology. So basically cloud is just calling the VCCTL.
Yeah.
So cloud can call this XM commands for SEN.
So I can tomorrow have a set of physical servers. Just that the VC client will change in that case. It would be such that instead of using vCTL, it will be using that's provided by SEN or any other virtualization.
Okay, so one more question. How are you ensuring availability of all the components in this cloud? Right? For example,
Okay. Currently, Cloud daemon is a single process. It actually gets triggered every 10 minutes. So even if it fails at one point, it will actually get restarted after another 5 minutes or so. So there will be a delay time in actually setting up the servers. But again, we have actually monitoring tied up to that as well, so that it actually gets noticed.
So even the daemon is down, so there is the data is stored in SQLite DB. So when the daemon restarts, it will take the data from DB and then do the operation.
There won't be any data loss as such.
There is no data loss.
And most of the activities are kind of like idempotent. So say the Cloud daemon indeed actually made an entry into host DB, but failed to create a physical host. In that case, maybe the next time it runs, it will see that there is actually an entry actually existing for that particular host. Then it will actually continue with the rest of the steps.
So if you want to compile the kernel, then you have to stop all these things.
If if there is a kernel upgrade, then we have to either move out the VMs using live migration, or we have to shut it down. So the thing is, most of our applications are BCP compliant. So even if the application hosted on one server goes down, there would be other services that can actually take that up. We will try to ensure that all the services or related to a particular component are not hosted on the same physical host. So it gets distributed. So even if one goes down, there will be a reduced capacity, but services would still be up. So So this is the future. Currently, migration is a manual process. We are actually trying to automate that. Then DB provisioning. Currently, like I stated earlier, we don't provision DBs on virtual machines, but we do have so many small database clusters where the data size itself is small and the number of reads and writes that happen to it is also small. So, but we still need to provision 2 to 3 servers for those DBs because data is critical to have replication and redundancy and all. So the idea is to actually overcome that limitation by actually using high-speed flash drives for this particular virtual machines. So that Biridan drives, which has a very high throughput compared to SCSI or SAS drives. So it's still a work in progress. Currently, OpenVC is used for provisioning virtual machines. The idea is to actually have it as a full infrastructure management tool, where load balancers and physical hosts are all provisioned using cloud itself. Then auto scaling. Cloud, apart from the web interface and command line tool, it provides APIs using which you can actually create or delete a virtual machine programmatically. So that will help in, say, you can actually then scale up or scale down your infrastructure based on traffic loads or any other requirements. Then TCO, it's total cost of operation. It's actually a way of holding each team accountable to the amount of resources that's actually used by them. Currently, it's not being audited. So that's it. Any question? Yeah, we use LDAP for authenticating that. So currently, ops are the main guys who actually create or delete a virtual machine. So we authenticate that before actually provisioning them. And there was a plan to actually, we had an environment called Silverline, where even the devs were actually provided small virtual machines for a kind of like sandbox. So in that cases, we limit the amount of virtual machines that's actually can be created by a particular user, like that. We use LDAP basically for access control.
Another question I had was, you kind of said that when applications are, provisioned.
Applications are?
Basically provisioned. You kind of ensure that, let's say if you want like 4 copies of an application for BCP, you ensure they are all not provisioned on the same physical host.
Yeah.
Right. So which layer sort of in that diagram is taking care of that?
Okay. So the cloud, The front end is actually, while creating, the front end itself actually provisions a virtual machine. So currently it uses its strategy is that it would be put on a host with the least number of virtual machines. So it needn't actually necessarily guarantee that the server, or say you are creating 4 web servers. Say you are, it needn't actually guarantee that all 4 won't go into the same server, but it is highly likely that it will be spread out. And again, you can explicitly mention a physical host where you want to actually have the server set up. So that way it's possible to do that. Unit's a monitoring tool. It provides graphing and that provides alerting. This provides in-depth different based on different resources. You can have a graph like be it CPU or memory and all that. The utilization over a period of time. We mainly use Nagios for alerting. Currently, it's not open source. It's developed in-house. We do have plans, but still discussing on it.